In this video, we will present the use case of Pavement Core Analysis. Let's start by logging in. So this is the reference document that we will use for this testing. As I said, it is about Pavement Core Analysis. Companies building roads are dividing the entire length of the road in sections of about 3,000, 4,000 feet. And for each section, a sample is taken every 1,000 linear feet. This means about 300 meters, every 300 meters. And the entire lot, as I said, it's about 4,000 feet, which means 1.2 kilometers. So for a construction lot, 4 samples have to be collected. Let's start with the standards used by this testing. Is this one? And this one. Now let's check the measurement units used in this document. We have gram, millimeter, percentage, and that's it. Let's check. So we have gram, percentage, and millimeter. So the measurement units are already present. Let's continue analyzing the document. So let's see what are the measurements that have to be performed by the laboratory. So it's the core height. Let's start designing the form. Add new form. Okay, move the form to the bottom and start editing the design of the form. And let's add a new parameter. This is a measurement. This is a numeric value, as we can see in the document. Also, we have an arbitrary number of samples we collect. Therefore, this core height, it's an array of data. So it's an array. It's not a parameter because this one will be displayed in the certification and into the quality certificate. As it is mentioned here, no single core can fall below 45 millimeters. So this is a hard restriction. Okay. Measurement unit, it's millimeter. Save. Add a new parameter. Dry mass. It's also a numeric value. It's also an array. This time this is just a measurement. It will not be displayed in testing reports or quality certificate. Measurement unit. It's gram. We will save. Saturated surface dry mass. It's another parameter. Also, it's a numeric value. It's also an array. It's also a parameter. It's not displayed in any testing report or quality certificate. And it's also gram. Next, submerged mass. It's also numeric. It's also an array. It's a parameter. It's not displayed anywhere. Measurement unit. It's also gram. Save. These are the measurements, and now we will add the calculations. And we will start with core gravity, core specific gravity, this one, which must be present in the report with 3 decimal places. Let's add it. It's also numeric. It's an array. It's not a parameter because it will be displayed in the final report here. Measurement unit. No measurement unit. Okay. Next. Average pavement thickness has to be reported. It's also a numeric value. It's not an array. It's not a parameter because it will be displayed in testing report. Measurement unit is millimeter. Next, average compaction level. It's also numeric value. It's not an array, it's not a parameter, it's displayed into the reports, measurement unit, percentage, save. Next one, compaction standard deviation. It's a value, it's not an array. It's presented in testing reports and quality certificate. It's percentage. Okay. And we also have the core sample count, which is an integer, will be displayed in reports, testing reports and certificate. No measurement unit. And these are all form parameters. Let's put the formula for the calculated fields. First, we will start with average lot pavement thickness. It's a calculated field. And we will calculate the average. Save. Next one, it's the average compaction level. This one, it's a calculated field. Actually, no, this is not correct, because C, it's submerged mass, is not correct. In place compaction is this one, and the average compaction level it's an average of these values. So let's correct the formula, edit. It's the average of CI, and CI, it's calculated with this formula, GMB divided by GMM and multiplied with 100. GMM is this value, 2.460, and GMB is A divided by B minus C. A divided by B minus C. Okay, I think this is the formula. Save. Okay, now let's calculate the compaction standard deviation. Compaction standard deviation, it's a formula. Like this. Divided by the number of samples minus 1, and SDM is CI minus average of compaction square. CI is GMB divided by GMM and multiplied with 100. GMM is 2.460 and GMB is 'A' divided by B minus C. Okay. Sample count it's calculated this one. Save. And core specific gravity It's again A divided by B minus C. But as a result, we will put this value with only 3 decimal places. Okay, let's arrange the form a little bit. Let's put this one on top. Specific gravity. Compaction. Compaction deviation. And core count. Okay, let's submit the form and start form validation. Okay, we forgot something. We see that all these data are related. For each core height, we have a corresponding dry mass. We have a corresponding saturated surface dry mass, and also we have a corresponding submerged mass. All this correspondence, it means that there is a relation between this data. How are we going to express this relation is by grouping this data together by using an identifier Okay, so they are grouped together now. We can start at the validation tests. And we will copy the data from the form. This one is core height. This one. This one. This one. Okay, next line. Next sample is this one. this one, this one, and this one. And we have added all the measurements data. Now let's add the expected results. For specific gravity, the expected results for a specific gravity are, let's put this one, this one, and now let's add the average pavement thickness. The expected value is this one. Average compaction is this one. Standard deviation is this one. And sample count is 4. Let's save. Okay, we can see that we have some problems. Core sample count, it should be 4. The expected value should be 4. Edit, it should be 4. Okay, this one is solved. For the compaction, okay, let's start with core specific gravity. The core specific gravity has to be reported with 3 decimal places. Therefore, from these ones, we have to round these values to 3 decimal places. Like this. Like this. Like this. And like this. Okay. We are good in here. The calculated values are the same as the expected values. Now the compaction, average compaction, should be reported final compaction must be reported with only 1 decimal place. So the calculated value is not correct. 1 decimal place, and the expected value is 93 0.9, 93.9 is this one. Save. The standard deviation should be reported with 2 decimal places. Two decimal places. Okay, and the expected value is 0.47. 0.47. Okay, and now we are all green. So we can validate the form. And we can start using it. Let's define a material. Add a new material. Pavement cores. Save. And now let's define the specification for this material. Add a new specification. Pavement cores. Details. Add a new test. Okay. We forgot to add the associated test for this material. Pavement cores. Add tests. Applicable tests. Core high. Specific gravity, average compaction, standard deviation, and compaction count. Save. Okay. Let's try to edit the specification again. Add a new test. The core height must be no single core can fall below 45 millimeters. So it should be greater or equal to 45. We will add some test data. Let's say we have 44.5. We expect the result to be no. Let's add 45. We expect the results to be yes. And let's add 45.8. We expect the result to be yes. Okay, the formula is validated. Add another test. Core specific gravity. This just has to show into the report. Any positive number will do. Let's add the test 0. It's okay. 0.5. The expected results is pass. And the formula is correct. Let's continue. Average pavement thickness should be greater or equal to 50. Greater or equal to 50. So if we have a 49.6, we expected the result. We expect the test to fail. If we have 50, we expected the test to pass. If we have 50.5, we expect the result to pass. Okay, next. Average compaction. It must be between 92 and 97. Greater or equal to 92. And also smaller than 97. Okay, we will add some test data to validate the condition. For instance, we have 91.2. We expect the test to fail. If we have 92, we expect the result to pass. If we have 94.2 or 2.7, we expect test to pass. If we have 97, we expect test to pass. And if we have 97.1, we expect test to fail. Okay. Add one more test. Standard deviation. For standard deviation, the value must be smaller or equal to 1.3. Smaller or equal to 1.3. If we have 0.68, we expect the result to pass. If we have 1.3, we expect the result to pass. But if we have 1.32, we expect the result to fail. Okay, the condition is good. Add one more, the last one. Core sample count. It should be greater or equal to 3. Greater or equal to 3. Okay, if we have 2, we expect to fail. If we have 3, we expect to pass. And if we have 4, we expect to pass. Okay, the specification has been validated. Let's submit it. And we completed the specification. Now let's make a sample reception. So let's add a certification sample. Select the material, pavement cores, batch code, submit the sample, and start testing. Let's select the form. And add the data, measurements data. We will take the same data used in validating the form. We'll take this one, this one, this one, this one, add another sample, is this one, this one, this one, and this one. And all the data is added. Let's also add a comment and save changes. Now we can see the form filled with data. This is a card format, but we can switch to table view to have a better look on the data. Here we can see the measurements. And here we can see the calculation results. Let's try to publish the testing report. The data hasn't been reported yet, is visible just for the laboratory. In order to be published to the laboratory clients, it must be made public. It will be reported. Now we can preview with the actual data. Everything looks as expected. Therefore, we will submit the report And now on the bottom of this page, we can view the submitted report with the actual data. However, the certification is not yet completed. The certification is done actually by filling the quality certificate. We will create a certification report, which is different from the testing report. The testing report is submitted by the laboratory personnel, but the quality certificate is prepared by the person in charge with quality assurance within the organization. One quality certificate can be composed of one or multiple testing reports. If the company has multiple departments, each department will perform its tests on a batch sample, and each one will release its own testing report, but the final report will be compiled by the quality control responsible. So we can see our sample pending for certification. We will add it, analyze the data. We can see the specification if we need it. We can consult the source of data used to compose this report, and we can analyze the result automatically, and let's submit the certificate. The certificate is submitted, and with this one, the testing process for this batch is completed. That's it. Please like, subscribe. Bye.